Today we are going to look at robotics. You see, robotic is one of the essential technology tools and equipment that enhances our work. So when we talk about the robotic, what does it mean? In your own understanding or in my own understanding, I would say that it's a digital and analog system designed to help human being work easier and faster, and that is robotic. Let's quickly move on to uh, what is the robotic methodology. Say we are going to look at the methodologies of robotics. One, robotics methodology is a step-by-step approach engineers and designers follow when building a robot. So let's say you are going to design a robot. You need a methodology. You need to do a background checkup before you can able to set up a robotic. And then before that, you need to look at the steps by steps approach or method that you use to design a robotic. That's what we talk about methodology. So without a clear methodology, you might build something that looks like a robot, but it does not actually work with it. Your robot solves a real problem and efficiently. That is robotic. Now, let's look at the step of robotic methodology. We have below are 7 steps every robotic designer follows. That is problem identification. So you must able to understand that the robot that you are building, you need to find a problem so that the robot is going to solve the problem. Then that is problem identification. When we talk about the problem identification, what happens here? Clearly state that the problem you want to robot to solve it for you. That is problem identification. Then we talk about the research. You see, you need to gather information about the existing solutions and technologies. What does it mean by existing solution? Let me say they are information that you need and the information that already exists. So you need to find out all that research. You need to do inquiries. You need to do research so that you can able to perform very well. Then we talk about design. Design is like a sketch or a plan how the robot will look and function. That is design. The way it give instruction for the robotic to be function. Then we have the component selection. You need to choose the right parts, sensors, motors, microcontrollers, actuators, and accelerators. So you're supposed to also do a component selection, and this is very important because without this thing you can't make a robot. So very good robot must have this part, sensors, motors, actuators, and then microcontrollers. And then let's look at number 5. That is the building assembly. What does it mean by the building assembly? It's also put the physical robot together based on their design, and then programming the way you want the robotic to behave. And then the last one, you need to do testing and evaluation. That's the way you want the robotic to be. You need to do what testing and evaluation to see that the robot is very fixed at the movement, or the movement the robotic is very well prepared or is very well built so that it can also interest for people to also have them. And then let's move on. What are the analog and digital system? So in robotic and electronics, two types of signals carry information, that is analog and then digital. So I said that we have analog and digital systems. In robotic and electronics, two types of signals carry information, that is analog and then digital. They also take the information. Now I want to talk about the analog systems. Analog signal changes continuously. It can take any value within a range. Imagine a sliding or volume of dial on a radio. As you turn it, the sound changes smoothly from silent to loud. There is no jumping from one value to the next. It flows continuously. So that's it. The analog systems. It means that the information must flow very nice and continuously. Examples of analog component are thermometers, mercury, and then analog clocks with hands, microphones, and analog radio, and etc. Let's quickly move on. Then we have a key feature like continuous signal values is also very important. Let's move on to digital systems. When we talk about the digital systems, a digital signal only uses two values, that is on one or one off. Think of a light switch, it's either on or off, nothing in between. Computers, smartphones, and most modern electronics are digital. And examples are digital components are microcontrollers, and then like Arduino, digital clocks, ELD indicators and pairs, meters, and then key features, discrete signal only two states, 0 and 1. So let's move on to slide by slide comparison. When you look at the features, you will see that you have a features of an analog and a digital system. When you talk about the features, you see that a signal type continuous, that's analog, and then when you look at the digital system, it's also discrete, 0 or 1, and then only. And when you look at the ranges between analog system and then digital system, when you talk about the ranges, you see that ranges is infinite values in a range, that is analog system. But when you look at the digital system, only two values, that's 0 and 1. When you look at the future analog system, real life analog clock, then digital clock. Let's say examples, analog system are thermometer, and then when you talk about the digital, you talk about the computer. So in common in robotics we have sensors, that is temperature and then etc. And then when we talk about the digital, we have also a microcontroller. As we are moving on, how digital and analog system work together. In a real robot, analog and the digital system must work side by side. Analog sensor collect data from the environment like temperature or light, as we already talked about it. And then digital component process that data and can make a decisions. Let me go it again so that you can able to understand it clearly. I said that in real robots, analog and digital system must work side by side. That's in the real robot. And the analog sensors collect data from the environment, like a temperature or like the light, as I've been talking earlier. And a digital component process that data and make a decisions. So a real robot, analog and digital system must work side by side. So analog, and when you design a robot, and the robot designing, analog and digital must work hand by hand or side by side. Analog sensors collect data from the environment, like temperature and the light. And then digital also make a decisions or process information or process the data to make a decisions. That's it, they go by hand by hand. Example, a robot that avoids obstacles. Let's take this thing for example. A robot that avoids obstacles. Analog in-flight sensor detect how close an object is. Continuous distance values, and then while a signal is sent to a microcontroller digital which reads the value. I hope you understand. Then the microcontroller decides if object is less than 20 centimeter, let's say less than 20 centimeter, then stop and turn. So that's it. Let me go over again. I said that in a real robot, analog and digital work by hand. An example is robot that avoid obstacle. Let's say you are designing a robot, and then there is obstacle. The robot is walking, but there's obstacle on the way of the robot. So when there's obstacle, what will happen? The analog in-flight sensor detect how close object is, and then continue distance values, and then the signal is sent to a microcontroller digital which reads the value, and then the microcontroller decide if object is less than 20 centimeter, then stop and turn. That's it. So that is how a robot works, or how it works. So let's